Yo, scholars, this is part 2 of some triangle congruence proofs on the Delta Math route. Today we're going to talk about skill 4.4b, triangle congruence proofs. All right, we have 4 of them. So let's get to it. All right. We are given AE is parallel to FD, AE is congruent to FD, and AC is congruent to BD, and we're trying to prove that some triangles are congruent. All right, let's go step by step. Got parallel lines, congruent sides, another pair of congruent sides in the triangle AC and BD. What do parallel lines give us? Well, if we remember from the last question we just did on 4.4a, we were talking about some inside of the Z lines that were called alternate interior angles. So when the lines are parallel, those angles must be congruent to each other. So we can say those angles, angle A and angle D, in this case, angle A and angle D are congruent to each other because parallel lines cut by a transversal form congruent alternate interior angles. It's just a fact. Okay, so we've got a pair of sides, a pair of angles, and another pair of sides that are congruent to each other. Side, angle, and this is the other side, side. So this triangle is sassy already, which means they must be congruent to each other. These sassy triangles. Triangle AEC and DFB are congruent to each other. Excuse me. AEC, DFB, by side, angle, side. That's it. That's all she wrote. There we go. Next question. All right, what are we trying to do? Prove triangles congruent. Let's see, what are we given? CA bisects angle BAD. What does that mean? It splits an angle in half. That means the two halves, the two angle halves must be congruent to each other. So angle BAC, that's this part of the angle here, AC is congruent to DAC on the other side, DAC, because that's what an angle bisector does. An angle bisector divides an angle into two congruent angles. And then we see that AC is part of both triangles and it's shared. It's got to be congruent to itself because it's itself. It's the same thing. That's using the reflexive property. Now let's see what we got marked going on here. We've got a pair of sides congruent between these two triangles, a pair of angles congruent, and now another pair of sides. So these triangles are sassy already, which means they are congruent by side, angle, side. Triangle ABC is congruent to triangle ADC, ABC and ADC by side, angle, side. Ta-da! Next. 2 more, guys. You're doing great. What are you trying to do? Prove triangles congruent. What are we given? An angle bisector again. All right. And then another pair of sides that are congruent. What does it mean to be an angle bisector? It means to split an angle perfectly in half, which means the two halves are congruent to each other. So we've got angle ACD on one side, ACD, congruent to BCD on the other side, BCD, because that's what an angle bisector does. It splits angles perfectly in half. Now we see these triangles are smashed next to each other, meaning they're sharing this side CD, which has to be congruent to itself because it is itself. It's part of both triangles, but it is itself. It's congruent to itself by the reflexive property. And now let's see what we have going on here. We got a pair of sides congruent. We got a pair of angles congruent. We got a pair of sides congruent. What do you know? We have a sassy situation. Triangles are now congruent. Triangle ACD ACD congruent to BCD by side, angle, side, try. Oh yeah. Okay. And one last proof to go. What are we trying to do? I think we're going to prove triangles congruent, triangle ABC and BAD. Got it. What are we given? We're given some sides are congruent of these two triangles. We're given some angles are congruent of these two triangles. We got a side and an angle. It's not quite enough yet. They are overlapping each other. They both have this bottom AB side. That is congruent to itself. That is using the reflexive property. Now I wonder, we've got a pair of sides, a pair of angles, a pair of sides. Is this a sassy situation? Oh, yes it is. This side whoop, is congruent to that one, right? And then the angles are congruent, and then the side is congruent right here. So it's sassy again. Wow, bunch of sassy triangles up here. Triangle ABC is congruent to triangle ABC, congruent to triangle BAD, because they are sassy. They're side angle sidesy. Yep, yep, yeparoo. Do. All done. All right, hope you enjoyed that as much as I did. Keep on that hustle, scholars. Love you so much.